12.6, radical equations. So we're going to be solving equations involving a square root. So if we take a look at the square root of 2x plus 9 is equal to 6, we need to find the value of x. So one of the first things that we need to do is to make sure that we isolate the square root, or isolate the radical. So it needs to be all by itself on one side of the equation. So now we need to figure out, okay, what can we do to undo the square root? So that would be squaring it. So you need to square both sides of the equation. Remember, like if we have the square root of 2 squared, that's really the square root of 2 times the square root of 2, which we know is 2. So squaring that square root gets rid of the square root. So let's do that to both sides. So we have to do the square root of 2x plus 9 equals 6. So let's square both sides. So we are left with 2x plus 9 equals 36. So if we solve that, we have 2x equals 36 minus 9, 27. Divide by 2, we get x equals 27 over 2. So now let's just check to make sure that our answer is correct. So if we check it, square root of 2 times 27 over 2 plus 9, is that equal to 6? 2 times 27 over 2 is equal to 27, so we have the square root of 27 plus 9. Is that equal to 6? 27 plus 9 is 36, so we have the square root of 36 is equal to 6, and that is true. So we got the correct answer. X equals 27 divided by 2. And you can write that as a fraction or a decimal, it doesn't really matter. Okay, so let's solve. So try these 4 examples and then come back to see the solution. Okay, so we have to square both sides of the equation to undo that square root. So we get x minus 4 equals 3 squared, which is 9. So that means x equals 5. So check that. Let's see, we have, oh, not 5. Silly me. We have to add 4 to both sides, so that means x equals 13. So if we check that, does the square root of 13 minus 4 equal 3? Well, 13 minus 4 is 9, and we know that the square root of 9 equals 3, so we are good. All right, let's try the next one. We have the square root of x minus 8 equals 2, so let's make sure we isolate the square root on one side. So we have to add 8 to both sides, so we get the square root of x equals 10. Now let's square both sides to get rid of the root. So we have x is equal to 100. Now let's check to verify that that's true. Does the square root of 100 minus 8 equal 2? Square root of 100 is 10. Not 100. So 10 minus 8, is that equal to? Yes, it does. So x equals 100 is correct. Right, the third one, our square root is already isolated on one side, so we can just go right ahead and square both sides. So we have 4x minus 1 equals 81. So that means 4x equals 82. So x must equal 82 divided by 4, which is 20.5. Now you can get it as a decimal, or you can write it as 82 over 4 as a fraction. Doesn't really matter to me. So let's check to verify that that's the correct answer. Does the square root of 4 times 20.5 minus 1 equal 9? So 4 times 20.5 is equal to 82. 82 minus 1 is 81. So does the square root of 81 equal 9? Yes, it does. Okay, this last one here, to subtract 32 from both sides to isolate the square root. So we have the square root of x is equal to negative 25. So let's square both sides. So that means x is equal to negative 25 squared. So remember, it's negative 25 times negative 25, which is equal to positive 625. So be careful when you square that. Don't forget the parentheses if you're using your calculator. All right, so let's check. Square root of 625 plus 32, is that equal to 7? So we have the square root of 625 is equal to 25. So 25 plus 32, is that equal to 7? No, it doesn't. 25 plus 32 is equal to 57, but that's not equal to 7. So let's see why that happens. Okay, so the reason that our check didn't work out is because x equals 625 is an extraneous solution. Okay, and that is because of this line right here. When we got down to the square root of x is equal to negative 25. When we're talking about the square root of x, we want the positive square root of x. Like, just like if I said, okay, what's the square root of 4? You're going to tell me positive 2, not negative 2. So as soon as you get down to something like this, where the square root of x is equal to a negative number, you know that your solution is going to be extraneous. Okay? So in this case, the solution to this equation is no solution. Nothing works. Alright? Let's try these two first, and then come back and see how you did. So again, if we take a look at the first one, we want to isolate the square root on one side of the equation. So let's add 3 to both sides. So we get the square root of x is equal to x plus 3. Okay, I know that there's two x's, or there's an x on both sides of the equation, but we still just want to isolate the square root on one side because that allows us to square both sides to undo the square root. So the square root of x squared is just x. And then we have to square x plus 3. So remember, that's like x plus 3 times x plus 3. So you have to simplify that. So we get x equals x squared plus 6x plus 9. Okay, now that we have completely simplified everything, we got rid of the square root. I noticed that I have an x squared there, so I either want to solve by factoring or I want to use the quadratic formula. So let's subtract x from both sides. Get 0 equals x squared plus 5x plus 9. So if I plug it into my quadratic formula, okay, so here's where we left off from the last video clip. I had to stop and restart again. So I left off here where we set our equation equal to 0. So we had 0 equals x squared plus 5x plus 9. And we needed to use the quadratic formula to solve for x. So if I plug it into the quadratic formula, this is what I get. So I end up with x is equal to negative 5 plus or minus the square root of negative 11. So as soon as you see you have to take the square root of a negative number, you can't do that. So there is no solution to this equation. All right, let's take a look at this next one. Okay, we have 5 minus the square root of 3x is equal to 2x. So we want to isolate the square root on both sides, so I subtracted 5 on both sides, and I got negative 3, or the negative square root of 3x equals 2x minus 5, so I have to get rid of that negative in front of the square root, so divide both sides by negative 1. Now that the square root is isolated on one side, square both sides, so the square root of 3x squared is just 3x, and then negative 2x plus 5 squared is that times itself. So I simplify that to get 3x equals 4x squared minus 20x plus 25. So I know I need to use the quadratic formula to solve this, so I have to make sure it's set equal to 0, so I subtracted 3x on both sides. So I end up with 0 equals 4x squared minus 23x plus 25. So if I plug that into the quadratic formula, my a is 4, my b is negative 23, and my c is 25. So there it is, substituted in, negative b plus or minus the square root of b squared minus 4ac all over 2a. And you get that x equals 4.29 or 1.46. Now I kind of ran out of room, so I didn't show the check here, but if you substitute 4.29 back into the original equation, you do not get an equality on both sides, so it is an extraneous solution. But if you substitute in 1.46, you do get both sides are equal to each other. So the only solution here would be x equals 1.46. Okay, so why don't you try these two problems first and then come back to see the solutions. All right, let's look at the square root of 3x minus 2 plus 4 equals 8. So let's isolate the square root on one side of the equation and then square both sides to get rid of the root. So we end up with 3x minus 2 equals 16. So that must mean x is equal to 18 over 3. So now we have to check it to make sure it's not extraneous. So if I substitute it back in, it does look like I get an equality on both sides. I do end up with the left side is equal to the right side. So x equals 18 over 3 is the solution. If we look at this next one now, I subtracted 6 to isolate the square root and then squared both sides. So I ended up with 3x is equal to x squared minus 12x plus 36 because that's what x minus 6 squared multiplies out to. Then I set the equation equal to 0 so that I could use the quadratic formula to then get that my x value was 12 or 3. So if I do the check for both of them, okay, it looks like if I substitute in x equals 12, I do end up with a true statement. So x equals 12 is a solution. But if I substitute in x equals 3, I do not end up with an equality. I end up with the statement 9 equals 3, which is not true. So that means x equals 3 is extraneous, so you can discard that as a solution and only use x equals 12. Okay, and that's it. Now go do your homework.